Good afternoon to everyone. My name is Rakesh Kumar Pradhan and today I represent the seminar report on DC booster. Contents: Introduction, Component required, Block diagram, Circuit operation, Advantages, Disadvantages, Application, Conclusion and Reference. Introduction: In this project, we build a DC booster circuit using a 555 timer IC. Boost converter is a non-isolated type of switch mode power supply that is used to step up the voltage. In other words, it gives a higher output voltage compared to the input voltage. Boost converter find usage in a lot of our daily equipment. There are very common power electronic circuits which are used extensively with the solar panels and other harvesting technology and are one of the most important circuits in today's time. Components required: timer IC, 555 timer IC, resistor 1K and 4.7K, capacitor 0.1 microfarad, 1000 microfarad and 470 picofarad, inductor 100 microhenry, battery 3 volt to 9 volt, IRF Z44N, MOSFET 1N4148, Zener diode, 1N5822 Scotty diode, 47K to 50K potential meter, connecting wires and 2-pin connector. Circuit diagram. In this circuit, we can construct it using commonly available active and passive components. The above circuit consists of two stages, the oscillator and boosting stage. Let's explore them in details. IC355 oscillator. The evergreen IC355 is configured in A-stable multivibrator mode which oscillates around 30 kHz with the help of RC components connect around it. To control the output voltage, we need to control IC355's duty cycle. To accomplish this, two fast switching diodes 1N4148 are connected anti-parallel between pin 7 and a 47K potential meter by rotating the potential meter clock and anti-clockwise. We can adjust its duty cycle and so does boost converter output voltage. Role of 4.7K at the output of potential meter. A 4.7K resistor is connected to 47K potential meter output terminal to limit the IC355's duty cycle to 90%. This is very important because if a user rotates the knob fully, the output will get saturated, i.e. 100% duty cycle. At 100% duty cycle, the MOSFET is on continuously and create full surge via inductor. And in a generally DC booster circuit, how the voltage is boosted. In two diagram, I explain in two diagram. First off, when the MOSFET is on. When the MOSFET is on, current passes through the inductor, through the MOSFET and finally to the ground. As mentioned earlier, the inductor does not allow sudden changes in the current, meaning when the MOSFET is on, inductor won't allow full current from the input to pass through the MOSFET and to the ground. Instead of the current will rise slowly in microsecond time frame. The slow rise in current is due to the inductor converting the current into magnetic field around it. Once the magnetic is fully built around it, there will be no opposing in the current flow. When the inductor has built sufficient magnetic field around it, in the above shown electrical polarity, the MOSFET will be turned off. Let's see the second figure when the MOSFET is off. When the MOSFET is turned off fully, the inductor can no longer support its magnetic field around it. So, its collapse on the inductor itself acts as a DC generator in the above shown electrical polarity. Now, if we take a look the The higher voltage passes through the diode and charges our electric capacitor. The diode prevents the charge flowing backward and ensures the stored charge is passed to a load connected to the output. The MOSFET is turned on again before the capacitor loses any significant amount of charge to maintain a steady voltage across output. Advantages: it simplifies the power supply system in the circuits. It provides a technique to extend potential voltage as required. It is also used in regulation and control of DC voltage. The output is well organized as positive or negative. Battery space can be reduced by using a converter. Disadvantages: switching converters lead to more noise. They are expensive as an external circuit is required. Choppers are inadequate due to unsteady voltage and current supply. Application: there are many applications and I mentioned the few of them. Just like hybrid electric circuit is known as electric vehicles, solar power systems, LED driver, LED backlight and flashlight. Conclusion: normal DC booster efficiency is 94.07, but in this project we have 100% efficiency. So we observe in this project is by varying the duty cycle, output voltage also vary. And reference. That's all for this my project. Thank you.